go. I asked David to lead that song tonight because I really don't think we have a clue. We sing about how great thou art, and we talk about the rolling thunder and the worlds he made, and those are laughable. And I think you'll see what I mean tonight. One of the things I want to do tonight is show you the majesty of the creation, how great it really is. Okay, I got to find the right place to do this. Where is the thing that sees this? Is it up there? Okay. All right, just a real quick review of last week. I hope this isn't too boring, but I feel like a week in between meetings we need to do a little bit of review. We looked at is faith reasonable in the 21st century, and we looked at the status of what makes something reasonable to us. And when it all boils down to is that things are reasonable to us because we're used to them. We're comfortable with them. We've experienced them many, many, many times. And it has relatively little to do with what we can really explain or logically prove. And I gave a lot of examples. I'm not going to do that tonight. I just want to remind you what we went over. We looked at logic and some logical fallacies, and the one I want you to remember is the circular argument. I call it anti-supernaturalism. There are those among us who have a presupposition that nothing supernatural can possibly exist. And therefore, they discard out of hand any evidence whatsoever. No matter how good it might be otherwise, they discard it if it is likely to prove the existence of the supernatural. The example I gave was a discussion I had with a friend of mine one time who went through this very same argument, and I was curious. So I asked him, what kind of evidence do you need? And he said, well, it'd have to be something that's impossible but observable. And I said, well, isn't the resurrection of Jesus Christ exactly that kind of evidence? And his reaction was interesting. He says, well, you don't believe that happened, did you? That's ridiculous. That would be supernatural. So this is an argument that you will see in various levels of sophistication. We went through the little story of flat land because I think it's an excellent way to visualize some of the things that happen in the Bible. Jesus appearing in the upper room with the apostles when the door was locked. Jesus about to be thrown over the cliff by the mob and simply walking through them and leaving. These things make some level of, they seem more plausible, I think, when you realize what the sphere in three-dimensional spaceland was able to do as seen from the people in flatland where there was only two dimensions. The extra dimension gave him the ability to do things that were impossible in flatland. And the analogy is that Jesus has a spiritual aspect that we don't have, that we can't see, that we can't measure in any way. And that allows him to do things that we cannot do. And we looked at some examples. Gravity, beginnings, infinity, God. These are all things that we have trouble getting our arms around because we're finite beings. We live within the bounds of space and time. Jesus didn't. But when something goes beyond those bounds, it's very, very difficult for us to conceive of it and to understand it. And the point of all this was that at the most basic level, if you ask enough questions, you get to a point, it doesn't matter whether it's in religion or in science or law, whatever, there are things that you simply have to accept as givens. Gravity is one of them. Gravity is a property of matter. And we really can't say a whole lot more about what it is or why it is than that. We can tell you all kinds of things about what it does, how it affects things, how it affects planets and orbits around suns and things like that. But when it comes down, you keep asking, what is it, what is it, what is it? Eventually, you just have to say, it's a property of matter. It's something we observe. And we've gotten very used to it, and we're comfortable with it. In the same way that we know a physical law to be true, or in the same way that we know that a man is guilty of murder and are willing to take his life, to that same degree, and in that same way, we can know that Jesus Christ is the Son of God, that there is a God, and that the Bible is His inspired Word. We're using exactly the same kind of logic. So, one must accept the existence of God, the inspiration of the Bible, the deity of Christ, on the very same basis that they make every other decision in life, on the basis of the available evidence and the decision that it most strongly supports. That's our only choice. Okay, tonight I want to look at Genesis 1 and lessons from space. And we're not going to go very deep into Genesis 1, basically Genesis 1:1 and maybe 1:16. Genesis, first of all, some assumptions. And my assumption is that Scripture must be inerrant. It must be accurate. It must be true. If there's a God, if God exists, and if He is the creator of all nature, everything that is, everything that we know, even things we don't know, and if the Bible is His inspired Word, then it stands to reason, doesn't it, that this Bible has to be consistent with what we observe in nature. Because He created it. He created nature, and He dictated the Bible, inspired the Bible. These are His words. So if that's His creation, and these are His words, the two have to be consistent. Now, I didn't say it had to explain everything. I said it has to be consistent. Where it makes statements about nature, they must be correct to the extent that they go. And that's what we're going to see in Genesis. We'll see that Genesis is not a detailed explanation of how everything was created. The basic message is it was created in the beginning by God. And it gives us some details, but it doesn't tell us, for example, what is meant by "and God spoke and things came into existence." We don't know what that process is. But we do know that God's the cause of it. Okay? So the Scriptures claim a few things I want to look at to begin with. Right off the bat, Genesis 1:1 says, "In the beginning, God created the heavens and the earth." In the beginning. And we'll look at how significant those three words are later on. But there's a lot in that one little claim there. God made in 16, God made two great lights, the greater to govern the day, the lesser to govern the night. And He also made stars. In Genesis chapter 22, when God told Abraham to sacrifice his son Isaac, his son whom God had promised that the promises His great nation would come through, God, after Abraham proves himself, God makes a promise to Abraham. And He says, "I will surely bless you and make your descendants as numerous as the stars in the sky and as the sands on the seashore." Now, Abraham was some kind of a Bedouin, I guess, and he'd probably never seen the seashore. If he had known this was a ridiculous comparison, right? How many stars can you go outside and count if you got 20/20 vision? Well, it's interesting. People have done that down through the ages, and not so much since telescope was invented, but prior to that, people went outside and they counted stars. And if you have good eyes, you can count on the order of about 2,000 stars. How does that compare with sands down at Gulf Shores? I would submit that I could take you down to Gulf Shores and sit you down in one place and say, count all the grains of sand and don't leave until you count them all. And you'd never leave that place. It's a ridiculous comparison on the surface. So let's look at this cosmos that the Bible says God created. What does it consist of? This is our sun. I'm sure you've seen this picture before. Sun is a very large, violent ball of gas, superheated, so hot that it strips the electrons off the atoms. It's powered by a nuclear reaction. Here's what the surface of it looks like. These are these streamers coming out are ionized gas, plasma, flowing along magnetic field lines. The field lines come out of solar sunspots. It's not a friendly place. It's when we talk about rolling thunder, the earth is much smaller than that little sunspot up there. In fact, I'll show you the earth in a minute, but the power, the energy is just unimaginable to us. Here's another view of what's going on the surface of the sun. And this is going on all the time. See the little blue dot down here? That's the earth to scale. Above that little cloud thing is a big chunk of ionized gas, superheated gas, 1,000,000 degrees, that's been blown off by the sun. And you see the size of it compared to the earth. But what's interesting is the sun is really not anything special in the cosmos. Here's the sun compared to the planets. You can see Jupiter on the left, and then over here, the first little dark spot there is Earth. It's almost invisible on the scale of the sun. The sun's big. God made the sun. That's one of the two lights He made, the one to govern the day. But here's the sun over here on the left, and we have Sirius and Pollux and Arcturus, much larger stars than our sun. But that's not all. Look at Arcturus compared to the sun, and the next one shows there's Arcturus down there, the arrow, and you've got Antares over here. And just for fun, let's put the orbit of the Earth up there. Now, Antares has a radius of 185 million miles. What was the distance from Earth to the sun? 93 million. There's the orbit of Earth. If you were to place Arcturus in the same spot our sun is, it would take you 105 years going 100 miles an hour steady, day in and day out, night after night, week after week, to get to the surface. You'd be 91 or 2 million miles below the surface of Arcturus if it were placed where our sun is. And by the way, even Mars, which is half again as far out as we are from the sun, Mars's orbit would also lie beneath the surface of Antares. In fact, Jupiter would lie just outside of the surface. So if you were to place this one star where our sun is, it would engulf about half of our solar system. One star. There's some big things out there, and we just don't really have a clue. And what I want you to remember through all of this is that whatever creates something has to be greater than the thing it creates, doesn't it? And it worries me sometimes when we're a little bit familiar with God, when we pray, when we lead communion. I think we need to remember who it is we're addressing and the awesome power. It's easy to say awesome power, But this universe he created is beyond our imagination. It's incredible. If you remember last week we talked about, tried to give you a feel for the distance from the Earth to the Sun, 93 million miles. That's called 1 astronomical unit, AU, 93 million miles. And you remember we said if you were to travel 100 miles an hour steadily from the time you left Earth to the time you reached the Sun, it would take 106 years. Well, we've got to think bigger than that tonight. And I'm going to spend a few minutes trying to help you see that. It's difficult to imagine. But let's look at the speed of light. Light travels 186,326 miles per second. Not per hour, per second. That's 7.5 times around the Earth in 1 second. Or that 106 years it took us to go to the Sun in 100 miles an hour, it makes it in about 7 seconds. Now, we got to take a giant leap here. I want to think about a light year. How far does light go in 1 year? That's the kind of scale we need to talk about distances in the cosmos. If light can go from here to the Sun in 7 seconds, and it would take us 106 years to do that, driving a car at 100 miles an hour. In a year's time, how far do you think light would go? A long ways. It's probably further than we can imagine, but it's scientific notation, 6 times 10 to the 12th, that's 6 with 12 zeros behind it, or 6 million miles. 6 million miles. If you were to drive 25 miles, say from here to Athens roughly, and for every one of those miles you multiplied it by 1,000, you would come up with 25,000 miles. So you would jump from going from here to Athens to going all the way around the world just by multiplying by 1,000. We're starting out here with 6 million miles, 60 million miles. 6 million miles, and each one of those miles we multiply by not 1,000, but 1,000,000. And that's 1 year. That's how far light travels in 1 year. Okay, so how do they measure this? Well, you know, the way you tell distances is by triangulation. You do that with your eyes without thinking. But basically, if you've got a separation here called the base of the triangle, and there it's 2 AU, and you go out some distance, it makes an angle. And if you go out further, the angle gets smaller and smaller as you go further and further out. So like your binoculars or your camera, you start adjusting, and pretty soon you get over to where it says infinity, and from then on out it doesn't change. That's because the angle's so small, the instrument can't measure it. But if you were to put them further apart, then you could measure further out. That would increase the angle. So what's the largest thing that we have available to us on Earth? Well, people used to think, well, we'll make it measurement on one side of the Earth, and 24 hours or 12 hours later we'll measure it on the other side. But you can do better than that. Every 6 months you can make a measurement, and you can measure it from way over on one side of the orbit around the Sun, and then wait until you get way around to the other side of the Sun, and you would be 2 astronomical units across the base. That would be 2 times 93 million miles. Now the angle's pretty good, and you can go out a long way. And when you go down to 3,600th of a degree, that's a small angle to measure. But when you make it that small of an angle, that distance then is called 1 parsec. 1 parsec. 1 parsec, let's see, the AU up there I said is 93 million miles, so it's twice that across the base. And 1 parsec is 3.3 light years, or 19 million miles. So that's the way they measure distances to stars, the close ones. That's only good out to about 100 parsecs, or about 330 light years. That's just the nearby things. That's our local cul-de-sac. So how do you measure when it gets beyond that? Well, there's the man named Hubble who the Hubble telescope's named for, discovered that everything is expanding. And this is the basis for the Big Bang theory. But you look at all the stars around us and they're all moving away. So you're all familiar with the Doppler effect. You may not know it by name, but you've been standing on the road and a car goes by with a horn blowing, and when it's coming to you, it has a high pitch, and as soon as it goes by, it drops. You know. Well, light does the same thing. If the source of the light is moving, then light in the front, the waves, since light always travels at the same speed, whether it's front or back, just like sound does, the waves get crunched up and it goes to a higher frequency. And if in the back they get stretched out and it's a lower frequency. But you don't hear that. What you do is you see it. You perceive it in a color change. So if stars are moving away from us, the light from those stars is shifted to a lower frequency, which means more toward red. And they call it the red shift. And the faster the star is going, the further into the red it shifts. And so they also noticed that the further away the stars, the ones that they could measure in parsecs, the further away they were, the faster they were moving. So now there's an assumption. And I'm telling you this because you need to be aware of some of the assumptions that are made. The assumption is that everything is moving, and it's moving in a linear way, so that the further away a star is, the faster it's going. And so then by measuring the amount of red shift, you can figure out how far away it is. So that's the way they make measurements. All right? Okay, I got ahead of my clicks here. So that's just what I just said. If you're in front of it, it would be a blue shift, but everything's moving away, so we have just a red shift on the stars. So let's look at some of these things in our neighborhood. This is a nebula, which is caused by a star that's exploded. And it's just a huge boiling cloud of gas. But some of these things are quite beautiful. They're quite large. This one is 2,000 light years from Earth. So it's already beyond what we could actually measure by triangulation, even using 2AU as a base. Here's another one. The Crab Nebula. Again, it's a star that died, and this is what's left of it. Stars, as they begin to burn out, they collapse, and when they collapse, that results in an explosion, and everything explodes, and they go into a large amount of gas and dust. Here's another one. Here's one that's exploded recently. You can see the ring where the gas is expanding outwards. In this area, new stars can form, the theory goes. Here's one it blew up, and it's 25 light years from the top to the bottom of that. 25 light years. That's how big that is. Remember, a light year, how far light can go in 1 year? Again, this is a cloud that's very far off, and these are all types of gas clouds. The blue is hydrogen, and the dark stuff is dust left over from star explosions and what have you. This is called the cat's paw or the bear paw nebula. It's visible in Scorpius. That's a formation you can see in the sky, a constellation in the summertime. It looked kind of like a scorpion with a tail. 5,500 light years away. This is probably a picture you've seen many times. It's called the Pillars of Creation, because these are huge, huge gas clouds, roughly a light year from top to bottom of these clouds. And in these clouds, the dust and gas is contracting, and as it contracts, it forms new stars. 7,000 light years away. This is another nebula. You can see bright new stars in it. This is in the constellation Orion, and it's just all kinds of chaos, but it's beautiful to look at. This is color-coded. The red is sulfur and hydrogen gases, and the green is sulfur and hydrogen, the orange and red are carbon-rich molecules. Another nebula. All these things are visible to us now because of large telescopes, in particular the Hubble telescope. Now, our star, the sun, and our solar system is part of a galaxy. And a galaxy is a cluster of stars. We can't see ours because we're in it, but if you were to look at the night sky, and you probably have done this on a very dark night, you can see a lot of stars across the sky. It's called the Milky Way. That's what we call our galaxy because of that. And this is a composite picture that's been taken of the Milky Way, and it's kind of what it looks like. But if we were to remove ourselves from the Milky Way, it would look something like this. It's a spiral galaxy of many, many, many stars. In fact, a typical galaxy like ours is on the order of 100,000 light years in diameter. 100,000 light years. So virtually everything I showed you a while ago, 4,000, 5,000 light years away, are all in our galaxy. They're in our local group of stars. And the population is on the order of 100 billion stars. 100 billion stars for a galaxy. It's just a typical number. We are located out toward the edge in one of these arms. And it's a good thing because we're out there on a little cul-de-sac where not much is going on. You don't want to be down here in the center. We would never be able to exist if we were near the center of a galaxy. There's too much radiation, too much heat, too much violence, too much stuff going on, collisions, all kind of things are happening down toward the center. In fact, if you look at the center, look at it on edge, you can see the center is even thicker. It's got a kind of a flying saucer shape there. But that's another galaxy that happens to be pointed edgewise to us, and you can see what they look like sideways. Again, this thing is 100,000 light years in diameter and contains 100 billion stars. So here's a close-up of the center of one, and you can see why I say we don't want to be in the center. So it just happens that we're out here on an arm in a little quiet neighborhood where we're safe, not much is going on. A lot of things have happened for us to be here that are interesting. This is an Andromeda galaxy. It's 2.5 million light years from us. It's very much like our own galaxy. It's a very large galaxy. It contains in excess of 100 billion stars. Although our galaxy has got fewer stars, it's more massive than this one. It has more dust and dark matter. There's another galaxy. There are many, many galaxies. Look at this one, 50 million light years away. 50 million light years away. This is the Sombrero galaxy because people think it looks like a hat. Again, it's a very large galaxy. It's 33 million light years away. All of these things are part of what Genesis says in those little few words, God created the heavens and the earth. And then in verse 16, He created the two great lights and then the stars. Centaurus A is a giant spiral galaxy, 11 million light years away. And this is interesting. You can't see it too well, but on the right bottom is a visual light. Up from there, radio waves, pictures taken in radio waves, and the top one is X-rays. And they made a composite of all of them. And what you see is, from the center of this galaxy, there's a white streak coming off to the left, up toward the upper left. See that? That is a beam of very energetic particles that have been blasted out of the center of this galaxy by a black hole that is about 10 million times the mass of our sun. The black hole powers this beam of, Suppose we were in the vicinity of something like that. I'm telling you, thunder and planets are not a big deal when you think about what God's created. This is called a bar galaxy. See up in the left, you can see it's got kind of a bar through it and two spirals off of it. This is the right, big picture is a close-up of its center, and you can the blue is color-coded to show new stars being formed out there. Here's a collision between two galaxies. Now, just think about the energy and the power. And remember, the Creator is greater than any of this. But here are two objects on the order of 80 to 100 light years in diameter, containing on the order of 100 billion stars, many of them thousands of times bigger than our sun. And these things are colliding. This is another picture of a collision, and the galaxy on the lower, in the center there, is being stripped of all of its hydrogen gas from a collision with the other one in the upper part. Here's another one that's been hit by the galaxy out to the right, and it shocked it, and you see a shock wave going out into space, thousands of light years in size. This is an interesting picture. This is from the Hubble telescope in visual light, and you're basically looking through a soda straw at a very, very small part of space. But you're looking very, very far out, 2.2 billion light years. 2.2 billion light years. Now, you know, I don't know if you're having trouble imagining this, but I do. You know, we talked about how long it takes to get from Earth to the sun, and that's nothing. Light does that in 7 seconds. This is 2.2 billion light years. How far light would go in 2.2 billion years? That's how far away these are, according to the best scientific methods. And what you see here, out there that far, are thousands of galaxies. And each one of those spots, there are virtually no single stars in this picture. You notice they're all fuzzy dots. That's because they're all galaxies. Each one of those little specks of light is 100 billion stars. So now let's go back and think about Abraham when God said, I'll make your descendants as numerous as the stars in the sky and the sands on the seashore. Not such a ridiculous comparison, is it? Of course, we had to wait a while to find that out. I don't think there's any way that Moses or Abraham could have known that that was a valid comparison, but we do today. How did the cosmos come into being? I want to go back and look at the first few words of Genesis. There's a question that has been posed, two questions that are basically the most fundamental questions you can think about in terms of why we're here. Why is there something rather than nothing? You know, if there was nothing, we wouldn't have any problems. First of all, we wouldn't be here to think about it. But if there was nothing to begin with and there remained nothing, then you don't have to worry about how something came from nothing. Right? I mean, it would be a lot easier problem. But there's something. So the question is, why is there something rather than nothing? How did something come into being? And the second question is, why is the something structured the way it is? We'll look at these questions a little bit, and maybe you'll understand a little bit more why they're so significant. There are three possibilities, since there is something. How did it come into being, the cosmos? One possibility is the universe is eternal. It's always been here. It'll always be here. Matter, space, time, energy, they're all eternal. They change, you know, things change, move around and all that, but it's always been here, what the universe is made of. That's the first possibility. And that was believed for a long time. The second possibility is the universe is not eternal. In the beginning, it created itself from nothing. Now, there are only three possibilities. That's the second one. That worries a lot of people a lot. How do you get something from nothing? How does nothing create itself? How does something create itself when it was nothing? These are not even easy questions to think about. The universe, third possibility, the universe is not eternal. In the beginning, it was created by something or someone. Now, if you can think of another possibility, I'd like to hear it. But I think that's the three. Whether you are a preacher or a scientist, you've got to somewhere light on one of those three possibilities. There are no more. Either it was always here or it had a beginning. If it had a beginning, there are only two ways it could get here. Either it created itself or something created it. No other possibilities. So maybe none of these are easy to conceive of, and I don't think they are, but I think that's the point. Science has not got better possibilities than we do. So there were theories that came along. The first theory had to do with the beginning. Well, let me go back. Maybe I don't know if I can or not. Okay, maybe not. There's the static universe, which is the eternal universe. And this is what Einstein originally thought, and he tried to work with it, and he considered it a great error on his part, because while he was diddling around with the eternal static universe, Hubble came along and figured out that everything was expanding and it wasn't stable and static, and Einstein missed a chance to discover something. The second one, well, and another theory on the first one, eternal universe, is that it oscillates. It was discovered that things are moving away. They're moving. It's not static. So it could still be eternal, but it could oscillate. It expands out until it kind of like you throw a ball up in the air and it goes up until it runs out of energy and it starts falling back. Well, the idea was the universe exploded out, goes out, and its gravity's pulling it, slows down, and it goes out so far and it starts coming back and it implodes again and explodes again and goes out. So you have this oscillating universe. A friend of mine, Hannes Alfvén, won the Nobel Prize in physics one year, and he said something interesting one time. He says, "I don't like the Big Bang theory very much. It's too much like God." And he was right in a way. The Big Bang is closer to the Bible than any of these others. So, in the beginning, the Bible says unapologetically there was a beginning. In the beginning. That's the first three words of the Bible. So you see, it wasn't so obvious until the last 20 or 30 years to the science community that there was a beginning. Many of them, people in my colleagues, at one time believed that there was no beginning, that the universe was eternal. So the Bible was a little bit out on the edge when it said there was a beginning. Not everybody believed that. So the static model, oscillating model, okay. Robert Jastrow, a very famous astronomer, says, now there are three lines of evidence: the motion of the galaxies, they're all moving away, the laws of thermodynamics, we'll talk about those later, and the life story of the stars all point to one conclusion. All indicate that the universe had a beginning. And everybody understands that now. It had a beginning. So the scientific community has finally come around into agreeing with Genesis. There was a beginning. In the beginning, God created the heavens and the earth. Now, the second part of that, God created the heavens and the earth, is interesting, because the other two possibilities are that it created itself, or something or someone created it. It either created itself or it was created by something else. And the Bible, again, unapologetically claims that God is the agent that created the cosmos. It didn't create itself. Well, let's look at some key words. The beginning, Bereshith, I guess is the way you pronounce it, means the commencement of time. It's not in the beginning. Some people want to say when God created, making room for the long ages of evolution. It says in the beginning, meaning that in the beginning, before the beginning, there was no time, there was no space, there was no matter, there was no energy, there was nothing. In the beginning, God created. In the beginning, the commencement of time. Elohim, God, means feared or reverenced. And if you think about what we've just seen, we need to have more fear and reverence for God. He is beyond anything we can imagine. The word create, bara, God made from nothing. Bara is sometimes used, doesn't always mean made from nothing. But in this case, virtually all scholars agree that the implication is that something was made from nothing. And if you don't agree with that, then you simply beg the question, because if God made the universe from something that already existed, then how did that come into existence? So you just push the question off. No, the Bible says God made things from nothing in the beginning. The heavens and the earth. There's an article before that, ETH, which the Jewish scholars say means the substance of the object. The object is the heavens and the earth. And so what he means when he says God created the heavens and the earth, it means he created the materials that they're made from. In other words, in the beginning, this first verse of Genesis says, in the beginning, God created time and space and matter, from which he then molded the earth and the stars and the planets in the later verses, which pretty much agrees with what we see, what we observe, not necessarily with all the theories. Okay, let's look at the Big Bang for a minute. The Big Bang holds that the universe began with a single immense explosion from which all matter, energy, time, space, the laws of physics, everything else came from. You think about it, before there was anything, there were no laws either. Where did the laws of physics that govern the way matter interacts come from? They had to come when matter was created. And, number two, the order we now see has evolved from that initial explosion, that initial chaos. Well, I want to think about how this compares with what we observe. Now, science is supposed to be about observation, right? The laws of nature are simply statements of what we observe. The laws of gravity, we've observed the objects fall and the rate at which they fall and all that so forth. And so Newton came up with these laws of motion and gravity. The laws of nature are just statements of our observations. So here's a theory. Here's a theory. How does it compare with observations? It's important for you to know this. The theory does not account for what it was that exploded. It starts with something. The Bible is ahead of it. The Bible says God created the universe from nothing. It explains where everything came from. God created it. The Big Bang doesn't explain anything about where it came from. It just talks about how things evolved. Something exploded and became organized and more complex and more organized as time went on. All right, let's look at some of the laws that are violated. These are some of the most fundamental laws of physics, of science. The law of cause and effect holds that for every effect, there must be an adequate antecedent cause. Now, what that means, that word antecedent, means that you don't blame the flood today on tomorrow's thunderstorm, right? The thunderstorm had to precede the flood. It's pretty obvious. Adequate means that, your son comes home and he's dented the fender on your car. And you say, son, how did that happen? And he says, oh, you wouldn't believe it, but a flea jumped in the way and dented my fender. It's not an adequate cause. So the cause is not just simple a cause and effect. The cause has to precede the effect, and it has to be adequate to produce the effect. One of the most fundamental laws that's been observed over and over and over. There are two laws of thermodynamics we need to be aware of. The first law says that matter and energy can neither be created nor destroyed. In the older forms, it used to say matter can be neither created nor destroyed. Since Einstein came along, we know that matter and energy can be transformed back and forth. But the combination, matter-energy, cannot be created or destroyed. That's our observation. Even in a nuclear reactor, where you destroy some matter, supposedly, you create energy, and there's a balance. It gets kind of like when you burn a lump of coal, you create heat. Of course, the matter and the coal are still with us, but matter energy can neither be created nor destroyed. Now, how does that compare with the idea that the universe created itself? What is the adequate antecedent cause if the universe created itself? And secondly, where did the matter come from? It had to be created. So these two laws are violated by the Big Bang Theory. Second law of thermodynamics is that total entropy or disorder of any isolated system can never be decreased in any reaction. Total entropy of the cosmos is therefore increasing toward a maximum. In other words, you never get more order when something happens. You burn a lump of coal and you start off with a nice condensed shaped piece of coal, and you burn it, and what do? You get carbon dioxide all over the place, and you can never get it back. That's disorder. Anything you do creates disorder. I'm a living example of entropy. I didn't used to look like this when I was younger. Okay, I'm getting more and more disordered. Everything winds down. Your car wears out. Your house rots. Everything winds down. It's the most fundamental thing we have ever observed, and it's been observed over and over and over and over and over with never a single exception. Everything winds down. Now, what about the Big Bang? It says we started with an explosion, and from that explosion, we have David. From a great explosion of just gas and whatever was there, blowing out in all directions, we have the earth. We have water. We have islands. We have plants. We have puppies. We have all the things that we see that are so organized. How does that compare with this law? You see, the theory violates the most sacred laws of science we have. So physics is violated, and it's going to be violated whether or not we try to scientifically have a beginning or whether God begins. In the beginning, physics has to be violated. If God created everything, as the Bible says, the creation process involved the creation of time, space, and matter, and structure, and all the things, just like it says. And during that period of creation, these laws didn't apply. They were violated. And if that bothers science, I'm sorry, but the scientific models, the theory, the Big Bang Theory, violates them just as much. You don't get around this problem. You can't have a creation without violating the laws that we observe on this side of the creation as everything winds down and becomes more and more disordered. You know, I suppose Adam and Eve had straight teeth. I've got crooked teeth. Our gene pool's gotten polluted. The Big Bang Theory does not avoid this dilemma. Let's look at some views of some outstanding physicists today. I don't know if you know about Stephen Hawking. You may have seen him. He's been on programs like Nova, I think. He's a British man. He has a debilitating disease. He has to talk with a machine. He has a machine to turn pages on his books. He's basically a living brain. He's trapped in this body that can't do anything. But he's one of the most brilliant men alive today. He says the odds against a universe like ours emerging out of something like the Big Bang are enormous. And look at his last sentence. I think there are clearly religious implications. Stephen Hawking. He's the guy that talks about black holes and things. Inflationary theory. This is another one. This is an attempt to get around the problem of, well, where did this thing the size of it? By the way, all of the stuff we looked at, I forgot to mention, all of those huge stars, the one that could engulf Earth and Mars, and the galaxies with 100 billion stars and the billions of galaxies, all of that came from something about the size of a basketball, according to the Big Bang. Okay, and so this is a theory that tries to tell you where the basketball came from. All right? Holds that the universe began spontaneously from nothing. There's no science basis for that. Stephen Hawking says the new inflationary model was a good attempt to explain why the universe is the way it is. In my personal opinion, the new inflationary model is now dead. Although, tongue-in-cheek, a lot of people do not seem to have heard of its demise and are still writing papers. G.K. Chesterton, it's absurd for the evolutionist to complain that it is unthinkable for an admittedly unthinkable God to make everything out of nothing, and then pretend that it is more thinkable that nothing should turn itself into something. Those are the two choices. And neither one of them is very easy for us to get our arms around, is it? But we should not apologize for believing that God did it, because there's nothing better. Werner von Braun said, speaking for myself, I can only say that the grandeur of the cosmos serves only to confirm my belief in the certainty of a creator. The universe, revealed through scientific inquiry, is the living witness that God has indeed been at work. Romans, Paul tells us, for since the creation of the world, God's invisible qualities, His eternal power, and we saw a little bit of that tonight, and divine nature have been clearly seen, being understood from what has been made, so that men are without excuse. And I would submit to you that our generation has less excuse than any other generation before us. We can see things that nobody else could imagine, and you've seen some of them tonight. We can understand the power and the majesty of God better than any other generation. We're without excuse. Okay, I think that's the last one. Next week, we're going to look at the uniqueness of planet Earth, special nature of planet Earth. We're going to compare it with our cousins in our solar system, and I think you'll be surprised. And I almost made it tonight. Thank you for coming. See you next week.